Okay, today we're going to be talking about rational expressions. Okay? So a rational expression is the ratio, or the comparison of two polynomials. Another way to think about this is that it is also a division. So for example, of rational expressions, these are all rational expressions. Here's a polynomial divided by another polynomial. These really are polynomials, numbers, they're just the constants. Okay? So the way we'll simplify rationals is the same that we simplify fractions. If we were to simplify this fraction, if I factored this, this would factor into 2 times 5 and 3 times 5. Then there's a common factor of 5 that can be canceled from the numerator and the denominator, which will leave simply 2 over 3, which is the simplified fraction of 10 over 15. So the same thing is going to happen with the rational expressions. First we're going to factor the polynomials, then we'll cancel factors that appear in both the numerator and the denominator. Okay? So in order to do this, we'll need to factor both the numerator and the denominator. I'll start with the denominator. Here I see there's a greatest common factor of 2m that can be taken out, and then I'm left with m minus 1. Now we'll factor the numerator, and you can do it in any manner that you wish. This will factor, let's see, to get to 2m I need a squared, 2m and an m. Then the factors of 3 are 1 and 3. I see a minus 1 down here, so I'm going to try this. But let's check ourselves. So 2m squared minus 2m's plus 3m's is a positive m, and then minus 3. So this factors. And now we can do the canceling. The m minus 1 will cancel there. And we're left with 2m plus 3 over 2m. Okay. Now this is as far as that we can go, because we can only cancel common factors. And factors are things that are multiplied together, not common terms. So for example, I can't cancel the 2m over 2m, because this 2m is a term and this is a term. Okay. So it cannot be reduced any further because there's no common factors. Okay. In number 3, I can factor out a 2w, leaving behind a 5 minus w. Okay. Over, and here we can factor this into w and w. Let's do minus 5 and plus 2. Okay. Now, here, this factors into this. These factors are now very close, but they are not the same. Here we have a positive 5, and here a negative 5. Here, negative w, positive w. So the signs are actually different. Okay? So what that means, though, is I can make them the same. From here, 2w, what I'd like to factor out from here is a negative 1. If I do that, what I'll be left with then is if I take a negative from positive 5, it will be minus 5, and a negative from negative w would be positive w. And you can see that this would be the same if you redistribute this negative 1. So negative 1 and negative 5 would be positive 5. Negative 1 and positive w would be minus w. Over w minus 5 times w plus 2. Okay. Now we could rewrite this. We could commute, because addition commutes. We can write this as negative w. And let's put the negative, a negative 1 times positive 2w is negative 2w. And then I can commute these two to get w minus 5 over, and then we just copy the denominator again, w minus 5 times w plus 2. And then here we can see the common factors, which will cancel, leaving just minus 2w up top over w plus 2. Okay. Again, we cannot cancel the w's. Those are not common factors. They are common terms. Okay, now to multiply rational expressions, the same thing will happen. Remember, when you're multiplying fractions, you just multiply across. So that's a times c over b times d. But say if we had 24 over 27 times 81 over 12, we'd really like to do some canceling first, because I don't want to multiply 24 and 81 by hand and then find the factors of it. It would be easier for me to say 12 goes into itself once and into 24 2 times, while 9 goes into 27 3 times, and 9 goes into 81 9 times. But there's still some further canceling that could happen. 3 goes into itself once and into 9 3 times. So in the end, instead of doing the complicated factoring and complicated multiplication and then reducing, we can just say 2 times 3 is equal to 6. So we want to do the same thing here. If there's any canceling that can occur, we should do it. So for example, this w over that w cancels. 2 goes into 10 5 times, and 2 goes into 18 9 times. There's some more canceling that can happen. This 5 can cancel with this 5. 3 goes into 6 2 times, and into 9 3 times. Also, if there's a single y here and 2 y's up top, we're left with a y. And then I think that is all the canceling we can do, so let's rewrite what we have. We have the 2 here, an x here, and a y, so 2xy over w cubed is left. And we're multiplying that by just x squared is left. And then in the new denominator, just the 3. And from here, it's easier to see that I have no common factors left. So now I can just multiply across to get 2. X times x squared is x cubed, y, and 3 times w cubed is 3w cubed. Okay. Alright, let's continue. In number 2, we need to factor, so here we go. This one will factor into the factors of 12. Okay, we need an x and an x. The factors of 12 are 3 and 4, so we need a minus 4 plus 3 to get to a negative x. Here, the factors of 15 that will add or subtract to 2 are 3 and 5. So this will factor into x minus 5 and x plus 3. Here's our division bar. We're going to multiply that by our other division. Okay, the other fraction. So x squared minus 16 is the difference of 2 squares. So this factors into x minus 4, x plus 4. That's this one. And lastly, we have, this is a perfect square trinomial. This factors into x minus 4 to get to negative 8 and a positive 16. Now we can do the canceling. Here the x plus 3 cancels with this x plus 3. This x minus 4 cancels with that x minus 4. And there's also an x minus 4 here and here. So when we're done, the only thing we're left with in the numerator is the x plus 4 over, and the only thing we're left with in the denominator is x minus 5. Okay. So multiplying is really quite easy. We factor and cancel. Okay. Now dividing is the same thing as multiplying, except remember that we have to take the reciprocal of the second fraction. Then we do the same thing once we take the reciprocal, because we'll be multiplying. Okay. So let's do the flip here first. 4w plus 12 over 2w minus 10. I want to change this division to a multiplication, and to do that I need to take the reciprocal. W squared minus w minus 20 over w squared minus 9. And then we do the same thing. Okay? So here I see that there's a greatest common factor of 4. And below, there's also a greatest common factor of 2, leaving behind w minus 5. Then we're still multiplying. W squared minus w minus 20 will factor into w minus 5w plus 4. And w squared minus 9 is the difference of two squareds. So this factors into w plus 3, w minus 3. Now here we can do some canceling. This w plus 3 will cancel with this w plus 3, w minus 5 and w minus 5. But there's also canceling that we can do here among the coefficients. 2 goes into itself once, and into 4 2 times. So in the end, we have a 2 left and this w plus 4 in the numerator. And then in the denominator, just w minus 3. Okay. And then adding and subtracting rational expressions is the same thing as adding or subtracting fractions. To get that, you need a common denominator. Okay? Once you have the common denominators, then you can add the numerators. Okay? With rational expressions, though, we're going to need to know the factors of all denominators. So if they're not factored, we'll need to do this. Okay? Let's start with number 2 because it's a little bit easier. Okay. In number 2, we already have a common denominator, which means I can write this as one great big fraction. Okay. So what I mean by that is if I add 1/4 and 2/4, that's the same thing as 1 plus 2 over 4. Okay. So here's our common denominator. Here's the numerator of the first, y plus 1. And then we're going to subtract. Now here we're going to have to be careful. Let's put in parentheses. Because remember, we're going to be subtracting the second numerator. And now what this is, the reason I put the parentheses in is this is a polynomial. And when you're subtracting polynomials, remember that you have to distribute that negative. So this is equal to y plus 1. Then we're distributing the negative. So minus y plus 3. And then we just copy the denominator. Now we need to combine like terms at the top. And if we take y and subtract y, well, that goes to 0. And 1 plus 3, well, that's just 4. Over 3y minus 2. It's 3 times y. Okay. And that's all we can do with this. There's no simplification that can happen. Now in number 1, we don't have common denominators. The factors here are 5 and m. Well, this is really 2 times m times m. Okay. So we need to determine our least common denominator. To do that, you have to take all the unique factors. So here we have a 2 and here we have a 5. These both have to be represented in the common denominator. And then both terms have m. But we need to represent it more than one time, because there's 1m, but there's 2 m's. It's there 2 times. So we have to represent each factor the maximum amount of times in either denominator. Okay? So in this case, our least common denominator is 10m squared. Now, just like we do when we're adding fractions, we have to adjust each of these. So to get from 5m to 10m squared, I need to multiply by a 2 and an m. But I have to do that to the top and the bottom. For this one, to get from 2m squared to 10m squared, I have to multiply by 5. So now our denominator is 10m squared. I'm going to write it as one big fraction right now. The first numerator now is 3 times 2m, which is 6m. Since we were adding, we'll put the plus. And the second numerator is 7 times 5, which is 35. Now there's no common factors up here, so I can't factor it any further, which means there's no cancellation, and this will be our result. Now let's look down here at number 3. Now our least common denominator, m plus 5 is already factored. There's nothing we can take out of it. So its unique factor is just, we'll take it to be m plus 5. And the same with m minus 1. There's no additional factoring that we can do. So our least common denominator has to represent both of these. And since they're only represented once, that is to the first power, then our least common denominator will only do that. So let's write this as one big fraction. M plus 5 times m minus 1. Now, to get to m plus 5 times m minus 1, I have to multiply it by m minus 1 on the top and the bottom. So our numerator up here will look like 3 times m minus 1. Here we need to multiply by m plus 5 on top and bottom. And now what we have to be careful about is we're subtracting, okay? So subtracting 2 times m plus 5. Okay? Again, the same problem we had here. When you're subtracting, we're going to have to distribute that negative. So now, let's do our distribution. This is all over m plus 5, m minus 1. When I distribute the 3 through, we get 3m minus 3. And here we'll distribute not just the 2, the negative 2, to get minus 2m minus 10. Now we can combine like terms. 3m minus 2m is positive m, and minus 3 minus 10 is minus 13, over, and just copying the denominator, m plus 5, m minus 1. And so this is our result. M minus 13 will not cancel with either of these factors. Let's do a couple more. Okay, so here we have two denominators. To determine our least common denominator, we need to know the factors. So if we were to factor the first, this factors into x plus 4, x minus 3. And if we were to factor this denominator, this factors into x minus 4 times x plus 4. Okay, so we have two factors here, x plus 4, x minus 3. Now, and then here we also have an x minus 4. Here's an x plus 4. It's already represented here. The maximum amount of times that it's represented, it being x plus 4, here it's represented once, and in this denominator it's represented once. So we only represent it once in our least common denominator. Okay. So now that we know what our least common denominator is, let's prep and write this out. Then we have to adjust our fractions so that they have this denominator. So the x plus 4 and x minus 3 is already present here. So we just need to multiply by x minus 4 and x minus 4. Okay. So our new numerator looks like 3x times x minus 4. Now we'll adjust the second. We have the x minus 4 and the x plus 4, but we're missing the x minus 3. Now we'll write the second denominator, but remember we're subtracting, so this is minus x times x minus 3. Now let's simplify this. Rewriting our denominator, x plus 4 times x minus 3 times x minus 4. Let's distribute the 3x through. So 3x times x is 3x squared. 3x minus 4, 3x times minus 4 is minus 12x. Then distributing the negative x through, we get minus x squared plus 3x. And now we're ready to combine like terms. So we'll rewrite the common denominator. Now 3x squared minus x squared is 2x squared. Minus 12x plus 3x's is minus 9x. Which we could factor this further. We could factor an x out of the top, leaving 2x minus 9 over x plus 4, x minus 3, x minus 4. And from here, now that it's fully factored, we can see that there are no common factors. You don't have to multiply anything back out. Just leave your answer like so. Now in number 5, we face the same problem that we faced earlier. Here, where we had 5 minus w and w minus 5. we saw that these were not the same, but that we could make them to be the same by factoring a negative 1 from 5 minus w, and then they would cancel. So the same problem happens here. It's not that we have the same denominator. We have the opposite. So let me just copy this. Now here's a plus x minus 6. So I want to factor a negative out of this denominator, which would leave a negative 2 and a positive x. Just copying the first again. We have two issues to deal with here. Okay. Let's do the first. Let's commute these because addition commutes. So this becomes x minus 2, which is exactly what we wanted. Now we have the common denominator. But really what's happening here is we have to deal with our signs now. I'm adding a negative, and remember that's the same thing as subtracting. So that's the tricky one you have to watch out for. Remember to change the sign. Now we can write this with our common denominator, which is x minus 2. The first numerator stays the same. Then we have to put in the minus, but remember to open up the parentheses, because we're going to subtract the entire numerator from the second fraction. And now this will be over x minus 2. Nothing changes with the first part. But once we distribute that negative, we get minus x plus 6. Which we can combine like terms for. Will still be over our common denominator of x minus 2. 2x minus x is positive x. And 5 plus 6 is positive 11. And again, we have no common factors, so nothing can be canceled. Alright, so this is going to take a little bit of practice, but remember it works the same way as fractions, and that you need to know how to factor. If you're not up to speed on factoring yet, you need to practice that. As soon as you get factoring down, for the rest of the semester, things will go much easier for you. If you have any questions, send me an email.